Hello everyone, welcome back to the TechClout channel. Hope you are doing well. In today's video, we are going to discuss about OSI model and TCP/IP model. So along with this OSI and TCP/IP model, we will also discuss about their layers. So OSI has 7 layers and TCP/IP has 4 layers. So we will discuss each layer one by one. So let's first start with the OSI layer. So OSI layer, before OSI, there was a restriction, or you can call it a barrier. So what was happening, only same vendor device was able to communicate with the other same vendor device. Like it is a HP computer, so that time one HP computer can connect with only HP computer, other HP computer. There was no cross communication like a Dell computer can connect with HP computer. So to break this barrier, ISO developed a architecture, you can call a logical architecture, that is called as OSI, Open System Interconnection. So OSI called as Open System Interconnection. So the basic fundamental of this OSI model is that it has some layers that called as 7 layers. So it has 7 layers, and on behalf of those 7 layers, it define a logical network and effectively describe computer packets. It's also help you to transfer by using multiple layer of protocol. It's help you to transfer the data by using multiple layer of protocol. So let's see the history of OSI. So OSI first conduction or first initiative of the OSI creation was in 1970. So this was an initiative. This was an initiative. So in 1970, once this initiated, after that it needed some specification and then testing, then other thing. So this got tested and programmed and then developed and then launched in 1983. It got developed, and in 1984 it got launched or publicly available for everyone. So after the OSI, cross communication was started. Dell computer was able to connect with HP. So this was an open system interconnection. Anyone, any vendor can use this standard to communicate with each other. OSI was developed by ISO. So ISO, International Standard Organization. Okay, so OSI has 7 layers. So from starting from first layer, so the first layer is physical layer, then second one is data link layer, third network layer. Sometime we have heard layer 3, so that layer 3 is network layer. Then we have layer 4, transport layer. Then we have layer 5, session layer. Then layer 6, presentation layer. And the last, or you can say the top one, is application layer. So this is all about OSI as of now. We will discuss each layer one by one in the next slide. Now let's see the TCP/IP model. Let me remove these all. So TCP/IP model is also same as like OSI, but the difference between them, OSI is open system. It is a open system, or you can say open resource. So in OSI, developer was not bound to establish or develop their application. They can use their own tradition, you can say, or use their own way to configure or develop application. So it was not restricted. So for that reason, another model implemented, that is called as TCP/IP model. TCP/IP model. So basically this TCP/IP model helps you to determine how a specific computer should be connected to the internet. In OSI, we were seeing that vendor communication, HP to HP or HP to Dell. So this define that how a user is connecting to the internet, right? So it how it defined, so it defined by transmitting data between the host that are trying to communicate with each other. So it is specifically designed as a model to after highly reliable end and end-to-end bytes stream over the unreliable network. Over the unreliable network, it provide a reliable communication. That's why the TCP/IP model implemented. So the small bit about TCP/IP means transmission, control, protocol, and internet protocol. This is the full form of TCP/IP. TCP/IP has only 4 layers. So also this TCP/IP was developed in 1974. Not developed means initiated in 1974. But it takes some time, and then after development it did some testing. So that testing and all the development that is happened. So in 1983 it got tested and reprogrammed. So before the testing and the reprogram, it was owned by ARPANET. But to own this and to restructure this, DOD, Department of Defense, so that owned it in 1990, owned by DOD, and restructured and published. So this one is restricted. If you want to be in the market of computer, if you want to be in the market of network, you will have to follow the TCP/IP model. So this authorizes that how a computer is connecting with other computer over the internet reliably. This is all about TCP/IP model. Now let's see all of the OSI layer one by one. So after this, let's see some basic difference between OSI and TCP/IP layer. So here we have OSI and here we have TCP/IP. The first basic difference state OSI is a 7-layer model where TCP/IP is 4-layer model. OSI is a logical and conceptual model that define network communication for open system. So this one is logical and conceptual model, where TCP/IP helps to determine how a specific computer should connect to the internet and the data transmission happen. So how a computer connect to internet as well as about data transmission. Also this OSI, so the header of this OSI is 5 bytes. OSI has only 5 bytes header, where TCP has 20 bytes header. Also this OSI is open source. open source, so anybody open to change the standard according to their development requirement. So it is, you can just call it changeable kind of open source, changeable kind of model. And this one is a fixed model. In TCP/IP, it is restricted and accountable standard. So you are accountable and restricted to use this model. So this one is restricted and accountable. So OSI help to standardize router, switches, motherboard and hardware, where OSI only standardize router, switch, motherboard and other hardware, where TCP/IP help you to establish a connection between different types of computer. So TCP/IP primarily work on the behalf of establishment of two computer, two different type of computer. These are some basic difference between OSI and TCP/IP layer. Now let's discuss each layer of the OSI, because both of the layer having similar kind of layers, like it has TCP/IP has 4 layer, OSI has 7 layer. So let's see first the difference between them. Let me note it down. OSI, sorry, and TCP/IP again. OSI has layer 7, application layer, then presentation layer, then session layer, then after transport layer, then network layer, then data link, and the last or first one you can say physical layer. So this is all layer of OSI, where TCP, so in TCP/IP layer it has combined these all three upper layer and make one, so that called as this one is called as application layer, then transport layer as it is, so this one is transport layer. Now they have also kept similar. The second one is, you can call it network or internet layer, and again this both first and second layer is combined as host to host layer, host to host layer. So this is the layers of OSI and TCP. TCP has only 4, where OSI has 7. These all 3 layer, people also call it as upper layer. This transport layer is called as connection or backbone layer, and these 3 all called as lower layer. So these all are similar, their functionality is similar, their importance is similar, whatever they do, all of the backend process is similar. So now let's discuss one by one each layer. Let's first start with physical layer. The first one is physical layer. This layer has nothing to do with any protocol. So this layer only define electrical and physical specification of data connection. So this layer does not concern about any protocol or any higher layer of the OSI. So we can say the example of this layer is network adapter. Let me just put it down first. It is a concern to only electrical and physical specification. This only deals with the physical specification, physical connectivity. No concern to protocol or higher layer. And the example for this layer is network adapter. We call it also NIC card. The interface or the port we have in the device, in the computer, laptop, or in the router switch, that is called as network adapter or interface. Ethernet repeaters, hubs, network adapter, Ethernet repeaters, etc. So this was only related to cable, related to physical layer. You can also call it. Uh, it has only connection with the cable, electric wire, these all things. Now let's see the data link layer. So after physical layer, we have the second layer of OSI, that is data link layer. So this layer allow you to define the protocol to establish and terminate connection between two connected network device. So this is basically deals with, you have a computer, in between you have a switch, and then you have a computer. So this switch work on data link layer, you can say. So basically this is providing a communication between two computers within the same network. Okay, so data link layer, it has also, let me note down first, this allow you to establish and terminate connection between two network devices. Network device could be anything, computer, printer, server, anything. Network devices. This data link layer has two sub layer. It has two sub layer. First sub layer is MAC, that is called as media access control, and second one is called as LLC, logical link control. So there is difference between MAC and LLC. So MAC layer define how a device in a network gain access to the medium and permit to the transmit of data. So it basically define the MAC layer define how a device will be permitted to gain network access, where LLC defines. So this LLC layer is used for identity and encapsulating of the network layer protocol and allow us to find the error. LLC has to deal with error check or providing the error free connection on a network layer protocol. So this is the difference between MAC and LLC, also how the MAC and LLC works. So MAC has only nothing to do with other things, it just take care about the permission of the device, that how the device will gain access in the network, and LLC check for the error control for the network layer protocols. The devices works on this layer are switches, like for example switches works on L2 switches, layer 2 switches works on data link layer, hubs and bridge, they all are connecting devices, so they works on the data link layer. Now let's see the network access layer or network layer. So the third layer is network layer. So this layer provides capabilities of the functional and procedural sequence of the packet or data transfer from one node to other node in a different network. What it basically do, it provide communication between two different network. This is the basic fundamental of network layer. So it does not provide reliable or also does not guarantee the data delivery. It does not ensure that no ensure that data delivery or reliability. It does not ensure these things. So example of the network layer is, so if someone asks that what are the protocol or what are the things works on network layer, so you can simply say that IP address works on network layer, routing protocol, routing or routing protocol works on network layer as a physical device, router or next generation firewall, you can also call it a network layer device. So these are the device work on the network layer. Also this layer provide control over the network, that which network or which subnet can communicate with other network or other subnet. So what happened in this case, we have a network A, and then we have network B. So these are two different network. So this network layer provides communication between these two different network also control the traffic. It does not let anything go outside of the network. Now, after the network layer, let's see about the transport layer. Okay, so this transport layer ensure about the packet arrival to the host in a sequence without error, no loss of packet, or if the packet is lost, then it also provide the packet retransmission. So this layer, this one is layer 4, fourth layer, transport. So what it do, it provide the host to host connection in security. It also provide connection without error, no loss of packet, or if packet is lost, if packet loss, then packet retransmission. So these all things this transport layer provide. Also, this transport layer has two major protocol. It has two main protocol. Only these protocol define a whole architecture of the transport layer. The first one is TCP itself, transmission control protocol, and second is UDP, user datagram protocol. So these are the two major, or you can say the two main protocol of transport layer. About this TCP and UDP, we have already created a video and uploaded on the channel. The link will be in the description. Please go and watch that. Now let's move to the session layer. Now we are going to discuss about the upper layer. So this session layer is, sorry, fifth layer, session layer. So this session layer is responsible for basically creating, maintaining and terminating the connection between host. So it's basically handle important login or a password validation. What it maintain, so it provide support for session, or you can say connection creation, maintain the session, also terminate the session once the communication is completed, once the data transfer is completed. So these all things session layer do. It's also handle important logon, means who can logged in or who is authorized to log in. So this thing being identified and being managed and controlled by session layer. So logon as well as password validation. So there are three types of sessions. when we talk about session, so it has three types of session. You might have heard about these things. So the first is simplex, second half duplex, and third full duplex. Simplex is basically a one-way communicating type. So it has only one-way communication. One-way communication. Example of it, you can call it as a mouse or keyboard. So this is only for the one-way communication. Now this half duplex. So half duplex is a two-way directional communication, but only one at a time. It is two-way, like a walkie-talkie you have seen. So it is two-way, but it's still one at a time. Two-way, but one at a time. And full duplex, so full duplex is two-way directional as well as simultaneously communication. Means the example of half duplex is a walkie-talkie device. Now full duplex is two-way directional as well as simultaneously communicative. So at the same time you can communicate with the user like mobile. Nowadays on mobile both person can talk at the same time, means data is sharing at the same time. Two-way and simultaneously communication. So this is all about session layer. Now let's move and see the presentation layer. Presentation layer is the sixth layer. Okay, so this layer is responsible for the data representation by converting between application and network format. Whatever the format that application layer supports or that application support and the network layer supports, so this work between them and convert the data according to the format of application layer and network layer. You can also call it an intermediate protocol, intermediate layer between network and application layer. So it convert the data, encrypt the data, decrypt the data that can application layer accept. Basically this help the application layer to read the data in a correct format or in a user friendly format. So this is responsible for converting the data, encryption of data, decryption of data in a readable format for user or application layer. So this is all about application layer. Now let's see the last one and the most important, application layer. Application layer is also called as user interaction layer. You can also call it user interaction layer. So what happened? This layer interact with the user by the help of a software application. User interact with this layer with the help of software application. Interact with user with software application. Main function of the application layer is to identify communication partners. So the main function is to identifying communication partner, then determining the resource availability. Determining means the resource should be available to communicate with the user. So determining resource availability as well as communication synchronization, means whatever the communication is happening between the layers and between the user, so that should be synced, that should be synchronized. And the protocol works on this layer. Protocol works on this layer are, you can simply say HTTP or HTTPS, hypertext transfer protocol. This one is non-secure and this one is secure. FTP, file transfer protocol. TFTP, trivial file transfer protocol. SMTP, simple mail transfer protocol, etc. So these are some of the protocol who work on the application layer, that help the user to interact with the application layer. So this is all about the OSI and TCP. Hope you are able to understand this. If you like the video, please like, comment, subscribe and share with everyone. If you have any query, please comment and let us know. We will definitely reply. Thank you for the watching.